given this function f of x equals x squared plus 2, restrict the domain of the function f, so the function is 1 to 1 has an inverse function. Let's just look at a picture here first. X squared plus 2. So this is the picture. No, so notice at first if you pass a horizontal line through the graph, like y equals 6, it's not 1 to 1 because it fails the horizontal line test. So what you can do is restrict it. I mean, you can just look at it about here. I should make this smaller so it fits better. Give me 1 second here. There you go. So you see now this passes the horizontal line test. Look at this horizontal line, right? You see how it strikes it only one time everywhere? One time only. So for this version, we can say x is greater than or equal to 0. It's the domain. So in interval notation, you can write something like 0, comma, positive infinity. Like this, that's the domain. Now for the range part, you see how it begins at 2 right there. That's the lowest y coordinate, positive 2. And it goes up towards positive infinity, right? Y coordinates above 2 are always reached. So what you can say is that the range here, you can say is 2, comma, positive infinity as shown. So the domain and range of f is what I've written there. So that part is done. Okay, then it says you're going to find the inverse function. So how do we do that? What you want to do now is graph, for example, y equals x, and then form the inverse function using the graph. This is very important here, actually. This is 0, comma 2, with that dot. So 2, comma 0 is on the inverse in that location right there. Okay, do another point here. So let's see, this is 1, comma 3. So on the inverse, you have 3, comma 1. You just flip the x and the y coordinates, okay? Let's do one more here. So this one here is 2, comma 6 on the original. So 6, comma 2 is a point on the inverse right there. So we're looking for a function that will have those points. Okay, so let's carry this out. Now notice something else that's very important here. Well, again, I can show you this way just a few points. You can imagine if you mirror every other point across y equals x, it will make the graph here look complete. Let me do that maybe in a different color, in blue or something. You see, if I mirrored every other point here, it would make the graph look like this. It would make it look complete and solid. So that means something important. That means the domain of the inverse, where would that be? Think about it. So that begins at 2 and goes towards positive infinity. That's important. So domain of inverse, you would put bracket 2, comma, positive infinity, close with the parentheses. Okay, so it begins at 2, goes towards positive infinity. What about the range of the inverse? So range of inverse. Well, let's think about that for a second. You see, if you look at this piece here, and let me just do this. For any x that you choose here, the y coordinate on the inverse is always a positive. So see, there's 0, or along this piece is always a positive y coordinate on the inverse. This is always a positive y coordinate on the inverse, always a positive y coordinate, or it's 0 on the inverse. So the range of the inverse, let's write that down here, it would be 0 through positive infinity. So look at something very important here, fundamental relationship. The domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. Do you see the relationship, how the two switch around? Now let's actually find the inverse. Okay, let's carry that out next. So you're going to say f of x equals x squared plus 2. So first you replace y equals x squared plus 2. Then you interchange the variables. So you have your x equals y squared plus 2. Then you subtract. So x minus 2 equals y squared. Then you take square roots. So now be careful. It's going to be a plus or minus root of x minus 2 equals y. But then the y gets renamed here as f inverse of x. So you put a little negative up there. But because you've taken square roots, there's always a plus or minus part. But remember something important. That's why you want to look at the domain and the range and all that. Specifically, look at the range of the inverse. It's 0 or it's a positive y coordinate. So coming back to here, you got to discard the negative one. So in other words, you leave the following. F inverse of x is the positive, if you like, emphasize the positive x minus 2 under the root symbol. That's how you think about this. Okay, so leave a like if this is helpful.